Guys, we're going to go ahead and start our videos this week, and even though we're sheltering in place, math is no problema for us, right? All right, let's go ahead and get started. All right, our first video is going to be about a review of Unit 6. So this is going to be Unit 6 review, similarity. Now let's remember what our definition of similarity is. So when we have similar figures, we know that the corresponding angles are congruent. So the corresponding angles, the matching angles together are each congruent, and the sides are proportional. That means that we're going to make fractions of the different sides and set them all equal to each other. So your angles are congruent, your sides are proportional. Another thing that we learned in Unit 6 was scale factor. So we talked about scale factor. We had a little thing that we put in our notebook, and we said that scale factor was new divided by old. So you have your scale factor, you're going to take your new side divided by your old side. So if I had two triangles here, let's say we have triangle ABC, and triangle A prime, B prime, C prime. If I want to know the scale factor to bring me from triangle ABC onto A prime, B prime, C prime, I would take the new, which is this one here, over the old. So let's say this is 12, and let's say this is 3. So I'm going from triangle ABC onto A prime, B prime, C prime. So this is my new triangle. This is my old or my original triangle. So we're going to take the 3 over the 12. Now on a test for me, if you wrote 3 over 12, that's totally fine. But on a multiple choice test or the SAT, you would have to reduce that fraction or simplify that fraction to 1/4. So you do want to do that. All right, one of the big things that we did learn in similarity was triangle similarity. And there were 3 different ways to prove triangles similar. You had side, side, side similarity, side, angle, side similarity, and angle, angle similarity. Those were the only 2 ways, or excuse me, only 3 ways that you could prove triangles were congruent. So let's say we have 2 triangles here. So there's triangle CAT. And then let's say we have another triangle here. Oops. Okay, triangle DOG. So I want to know a couple things. I want to know if these 2 triangles are congruent, if they are, or if they're not, why or why not, and if they are congruent, or not congruent, similar, excuse me. If the 2 triangles are similar, why or why not, and what's a similarity statement? So the first question we're going to ask, are they similar? So when I'm looking at these 2 triangles, I have to decide, am I going to try to prove it similar by side, 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 angle, side, or angle, angle? Well, the first thing I would look at is I have 3 different sides given to me. I have no angle measurements, nothing in degrees here. So I can't use angle, angle, and I can't use side, angle, side. So I'm going to try side, side, side. Now this is where we would do like our fast food, small, medium, large. So I'm going to look at the small side from the first triangle and put it over the small side from the second triangle. So 3 is the small side of these 3 sides, 6 is the small side here. then I'm going to say, what's the medium side? 4/8. And then what's the large side? 5/10. So I'm looking, do these three fractions all equal the same thing? And yes, they do. So are they similar? Yes. Why are they similar? Side, side, side similarity. And then finally, if they are similar, you can write a similarity statement. If they're not similar, you cannot write a similarity statement. So to write your similarity statement, I'm going to go ahead and do triangle CAT. Oops, can't see that there. That's better. I'm going to do triangle CAT because I like cats. So if I look at the triangle here, CAT, to go from C to A, I went through the large side, and then A to T, I went through the small side. Large, small. So I have to follow that same pattern over here. The large side is 10, the small side is 6. So large, small, G-O-D. So I would say triangle CAT is similar to triangle GOD. And cats do kind of think they're gods, so that makes sense. All right, let's take a look at our next type of problem. We had something with angle bisectors. So you draw your triangle here, and you would bisect one of the angles, which means that these two are the same. And let's say I had 12 here. Well, this is x. Right, there we go. And we want to solve for x. So we can go ahead and make a proportion. We can say side over part, 12 over x, equals side over part, 17 over 8. So I took side over part equals side over part. Now we're going to go ahead and cross multiply, and this should be 17 over 8. So we'll bring down the equal sign here, and then I'm going to cross. 17 times x is 17x. If you want 12 times 8, we're going to get 96. So you start out, bring your equal sign down, go across. 17 times x, 17x. 12 times 8 is 96. Now I want to solve for x, so I'm going to divide by 17. So 96 divided by 17 is going to be 5.6. We also had something called side splitter. That's where we took a triangle and you had two lines that are parallel. So you've got your base here and then another line that's parallel. And let's say we want to make this x, and this is 3, do 7, and 10. And we want to go ahead and find x. So this is the one that you can actually see the fractions right in front of you from the diagram. If you took the line here and just kind of extended it out, you would have 3 over x equals 7 over 10. So you can look at this triangle and actually see your fractions. Then we're going to go ahead and do the same thing, cross multiply. Bring down my equal sign. I'm going to cross. 7 times x is 7x. 3 times 10 is 30. Divide by 7, x is equal to 4.3. Okay, there are two more problems I want to talk about. The next one is all about a mid-segment. So your mid-segment, remember that the mid-segment is equal to half times the base, or you can say that the base is equal to 2 times the mid-segment. So your relationship between your mid-segment of the triangle and the base is that the mid-segment is half, or you can say that the base is 2 times. Remember, a mid-segment actually touches the midpoints here. So let's say the base is 20. That means if I'm going to the mid-segment, I would divide by 2 to get 10 for the mid-segment. If I was given 10 as the mid-segment, I would multiply by 2 to get to the base. All right, the last question that I want to go over today talks about the ratio of areas. And so this is kind of a long question. We're going to say we have 2 figures in ratio, let's say 7:3. So we're starting with there. We have 2 figures. They could be any type of figures. They're similar figures and they have corresponding sides 7:3. Let's say the area of the smaller figure is 80 square inches. And we want to know what is the larger area. All right, so the first thing I'm going to notice is that we say 2 figures in ratio 7:3. Well, ratio is just a fancy word for fraction, so I'm going to make a fraction 7/3. And then I'm going to notice that the smaller area is 80. Smaller is 80. So out of my 2 numbers here, 3 is smaller than 7. So I have to line up the 80 here. And I want the larger area. So you make your fraction, line up smaller with smaller, larger with larger. And then the only thing you have to realize is that we're talking about area here, but we're talking about just length here. So to compare the two, we're going to keep this side the same, but we have to square this fraction. You have to square for the area. So 7 squared is 49. 3 squared is 9. Once you do that, once you square the area, then you're just going to cross multiply again. So we're going to pull down our equal sign and we're going to cross. 9 times x is 9x. And then 49 times 80 is 3,920. To solve for x, I'm just going to divide by 9. And I'm going to get 435.6, and that would be square inches. Okay, you're going to go ahead and do the Go Formative review, and let me know if you have any questions. Bye.